Lesson: Privacy by Design in AI. Privacy by Design in artificial intelligence is a foundational framework that integrates privacy into the development process of AI systems. This approach ensures that privacy is not an afterthought, but a core component of AI systems from their inception. As AI systems become more pervasive in society, handling vast amounts of personal data, the imperative to embed privacy considerations into their design becomes increasingly crucial. This lesson will explore actionable insights and practical tools that professionals can implement to enhance proficiency in responsible AI design, focusing specifically on privacy by design. At the heart of privacy by design is the principle of privacy as the default setting, ensuring that personal data is automatically protected in any given IT system or business practice. This principle is particularly pertinent in AI, where systems often infer sensitive information beyond the data explicitly provided by users. A practical application of this principle involves employing data minimization techniques, which mandate that an AI system only collects and processes the data necessary for its purpose. For instance, a recommendation algorithm does not need to access a user's entire browsing history if recent activity alone suffices to deliver accurate recommendations. Implementing privacy impact assessments is a practical tool that organizations can utilize to identify and mitigate privacy risks in AI systems. PIAs involve a systematic evaluation of how personal data is processed, identifying potential privacy risks, and addressing them early in the design process. By integrating PIAs into AI development, organizations can ensure compliance with regulatory requirements such as the General Data Protection Regulation and enhance trust with users. For example, Google's AI principles emphasize the importance of conducting impact assessments to address potential privacy and security concerns. Another critical component of privacy by design is transparency, which involves making AI processes understandable and accessible to users. This can be achieved through explainable AI, which aims to make AI decisions transparent and comprehensible. Tools like local interpretable model agnostic explanations and shapely additive explanations are examples of frameworks that provide insights into how AI models make decisions, allowing users to understand and contest these decisions if necessary. For instance, Lime helps to explain the predictions of any classifier by approximating it locally with an interpretable model, thereby enhancing user trust and accountability. The use of privacy-preserving techniques, such as differential privacy and federated learning, is another strategy to embed privacy into AI systems. Differential privacy ensures that the removal or addition of a single data point does not significantly affect the outcome of a data analysis, providing a mathematical guarantee of privacy. This technique is particularly useful in scenarios involving large datasets, such as training machine learning models on sensitive data. Federated learning, on the other hand, allows AI models to be trained across multiple devices or servers holding local data samples without exchanging them. This approach is particularly beneficial in scenarios like mobile keyboards, where user privacy is paramount. By processing data locally, federated learning minimizes the exposure of personal data, adhering to the principles of privacy by design. A case study involving Apple's use of differential privacy illustrates the practical application of this technique. Apple employs differential privacy to collect user data for improving its services while ensuring that individual data points cannot be traced back to specific users. This approach demonstrates a commitment to privacy by design by embedding privacy into the data collection and processing stages, thus maintaining user trust and compliance with privacy regulations. Moreover, embedding privacy into AI systems requires a cultural shift within organizations, emphasizing the importance of privacy in all aspects of development and deployment. This involves training and awareness programs that educate employees about the significance of privacy and how to implement privacy by design principles effectively. Organizations can leverage frameworks such as the NIST Privacy Framework, which provides a roadmap for organizations to identify and manage privacy risk through enterprise risk management processes. To further illustrate the importance of privacy by design, consider the case of the Cambridge Analytica scandal, where personal data of millions of Facebook users was harvested without consent and used for political advertising. This breach of privacy highlighted significant flaws in data handling practices and underscored the necessity of incorporating privacy considerations in the design phase of data-driven systems. By adopting a privacy by design approach, organizations can prevent such breaches by ensuring that privacy measures are embedded from the outset, thereby protecting user data and maintaining trust. In practice, implementing privacy by design requires a step-by-step approach that begins with understanding the data lifecycle and identifying potential privacy risks at each stage. This involves mapping out data flows, assessing the necessity of data collection, and determining the appropriate privacy-preserving techniques to apply. Professionals can use tools like data flow diagrams and privacy risk assessment templates to visualize and analyze data processes, aiding in the identification of privacy risks and the development of mitigation strategies. Moreover, regular audits and reviews of AI systems are essential to ensure ongoing compliance with privacy requirements and to address emerging risks. These audits should evaluate the effectiveness of implemented privacy measures, identify any gaps, and recommend improvements. Organizations can utilize privacy management software to streamline this process, providing a centralized platform for managing privacy policies, documenting compliance efforts, and tracking progress. In conclusion, privacy by design is a crucial framework for developing responsible AI systems that respect user privacy and comply with regulatory requirements. By integrating privacy considerations into the design process, organizations can build trust with users, mitigate privacy risks, and enhance the overall effectiveness of AI systems. Practical tools such as privacy impact assessments, explainable AI frameworks, privacy-preserving techniques, and cultural shifts within organizations are essential for implementing privacy by design successfully. Case studies and real-world examples further illustrate the importance and effectiveness of these strategies, providing professionals with actionable insights and tools to enhance their proficiency in responsible AI design.